In an extension of 9.2, we're going to talk about more on apothems. So we're going to do more examples. So now we are actually going to inscribe a shape in a circle. The center of a regular polygon is the center of its circumscribed circle. So this is important that this is actually going to lead into circles, which we'll do in a few weeks. But the center of a circle is also the center of a polygon. The distance from the center to any side of the regular polygon is called the apothem. Now make note that the apothem will always form a 90-degree angle to any side of the polygon. But we're going to take this one step further now. Let's just kind of go over this step by step, and you can determine what you want to put in your notes. So once again, the diagram shows a regular polygon inscribed in a circle. The center of the regular polygon and the radius of the regular polygon are the center and the radius of its circumscribed circle. Now you may think to yourself, well, how in the world can a polygon have a radius? That is something new. Pn, if you just look at the circle, segment Pn is the radius of that circle. Segment Pn is also the radius of the regular polygon. The distance from the center to any side of the regular polygon is called the apothem of a regular polygon. But make note of this. The apothem is the height to the base. So obviously it forms a 90-degree angle. But it's of an isosceles triangle. And that isosceles triangle has legs that are radii. You'll notice that segments PM and PN are radii. They're each a radius. So therefore, this makes these two red segments make an isosceles triangle. For a given regular polygon, think of an apothem as a segment and the apothem as a length. So you're like, what? What does that mean? An apothem is actually a segment, but the apothem would be the length. So if I ask for the apothem, you're going to give me a length. An apothem would be the segment itself. Now we also talked about the central angle. The central angle of a regular polygon is the angle formed by two radii, so right here, formed by two radii, drawn to consecutive vertices of the polygon. So for example, points M and N are the vertices, and the radii are drawn to them. To find the measure of the central angle, you already know this, you divide 360 degrees by the number of sides. Here's our example. A regular nonagon is inscribed in a circle with a radius of 4 units. Find the area of the nonagon. Now, it actually might give you the exact same shape, but it might not tell you anything about the circle, but it will tell you that this nonagon has a radius of 4. A lot of students have trouble with that because you've never realized that other shapes have radii. And they do because when we're looking at this, it's inscribed in a circle. So whether or not that circle is there, that circle does exist. Now, let's look at this circle with radii of 4. I'm going to draw that triangle, which is isosceles, L, K, and J, with an altitude, or in this case also an apothem, of segment LM, and we know these are 4. Now we know to find the area of any kind of regular polygon. Remember, this only works for regular polygons. We take 1/2 the apothem times the perimeter. Well, we don't have either one of these. So what do? Well, let's start finding the apothem. So the first thing I'm going to do is I'm going to take 360 and I'm going to divide it by 9, which gives me my central angle. So the measure of angle JLK is 360 divided by 9, which is 40 degrees. Because the apothem, segment LM, bisects the central angle, that means the measure of angle KLM is 20 degrees. So this angle right here is 20 degrees. If I want to find the apothem, which I'll just call, I'm just going to use as LM. I want to find LM. That's what I need to find. So I have a hypotenuse and I have adjacent from 20. So that means I'm going to use cosine. So cosine of 20 degrees equals LM over 4. Now once again, you could let that be X or A or whatever you want, but I want to know the length of LM divided by 4. So that means the length of LM, which is the apothem, is going to be 4 multiplied by cosine of 20 degrees. So I'm going to plug that in for A. Remember, I'm not going to round till the very end. So 4 cosine of 20 degrees is my apothem. But now I need to find the perimeter. Well, to find my perimeter, I need to find the length of JK. Well, I can find MK. Once again, remember that MK, I'm just redrawing this right here. I know that this is 20 and this is 4. We don't want to use the apothem because it's not an exact value. So I want to find the length of MK. Well, the length of MK, in accordance to 20 and 4, that'd be opposite over hypotenuse. So to find my perimeter, I can start by finding MK. So I can do sine of 20 degrees equals opposite, which is MK, over hypotenuse, which is 4. So to find the length of MK, I can take 4 multiplied by sine of 20 degrees. But remember, that's only half this triangle. I want the whole way across, so I just double it. So instead of 4 multiplied by sine 20 degrees, I can say that one side, this is one side, which is JK, is 8 sine of 20 degrees. That's one side. How many sides do I have? I have 9. So we can take 9, which is how many sides we have, multiplied by the length of one side, which is, and I'm going to run out of room here, 8 sine of 20 degrees. And if I multiply that all out, it would give me approximately 46.3 square units. This right here, once again, this represented our apothem, and the 9 times each side represented our perimeter. Now, I'm going to show you one other way you could have done this to find the length of, in this case, I believe it was JK. So, we needed the apothem, and we had to use our trig ratio to find the apothem. But we also needed the length of one side in order to find the perimeter. So we needed the length of JK. We knew this was 40 degrees, and we knew each side is 4. Remember what you could have done here. In order to find the missing side, we have the two sides and their included angle. We could have used, and put x here, we could have used the law of cosines. We could have done x squared equals the two sides, which are 4 squared and 4. We square them and add them together. Subtract 2, then multiply those same sides together, and then the cosine of 40 degrees. We would have gotten x squared equals 16 plus 16 minus, that'd be 8 times 4, which is 32, cosine of 40. Simplify that. And actually, we're going to take the square root. So it'll be the square root of 32 minus 32 cosine 40 degrees. Now, I know this is going to be weird because you're going to look at this and go, you've got to be kidding me. I can do this. You absolutely can. If you did, A equals 1/2 the apothem times the perimeter. A equals 1/2 the apothem. Now, the apothem was 4 cosine of 20 degrees. The perimeter, well, this right here is the length of one side. So we had, what was this, a nonagon? Yep, 9 sides. We could have taken 9 times all of that. And if you would have entered it in on your scientific or graphing calculator, you'd have actually gotten the same approximate answer as 46.3 square units. So you could have also used the law of cosines. It's completely up to you.